Hey, welcome back. It's video 3.
At least we didn't have to wait 24 hours for it.
No, at least you didn't have to wait. This way you can binge all 3 at one time, just like your favorite Netflix show. All right, problem 3. Square tiles were used to make the pattern below. Write an equation for the number of tiles t needed to make the nth figure. All right, now this can be a little tough. So what we need to do is we need to take a look at what's happening in this pattern. So this one is kind of hard to see. It doesn't really look like it fits. So I'm going to come back to this first figure. In figure 2, we have a square and then this tail, right? In figure 3, we have I'm starting to see a pattern. A square and a tail. In figure 4, we have a square and then a tail again. 1 second. All right, so the 4th figure is a 4x4 rectangle with a 1x4 tail. The 3rd rectangle has a 3x3 square and a 3x1 tail. 1 second, please. Sorry I realize it's not an extended break for you, but for me, that was about half an hour getting class started. It's good to see my homeroom. Thank you. All right, so we notice that we have a square and then the tail, and the square is the same as the figure number, right? So figure 2 has a square that's 2x2, and the tail is 1x2. That means this follows the pattern too, right? We have a 1x1 square and then a 1x1 tail. Okay, so that works. All right, so how do I find the equation of the square? Well, the square is just the figure number, I'm going to call the figure number n, times the figure number. And then the tail is always just the figure number. So to simplify that, we have n times n, which is n squared, plus we have n. Now obviously you could have written it as n times n plus 1, and that would have worked too. Okay, find the equivalent expression for, oh wait a second, that's part B, isn't it? So we have an expanded form expression and a factored form expression. Now on the unit test, that's going to be a big part of what you're going to be asked to do. Identify what is linear and what is not linear. All right, write an equation for the perimeter P of the nth figure. All right, so this is area. So now we need to look at the perimeter. And so I'll switch colors. I'm going to go with red. All right. And I'm going to erase my drawings there. All right. So I have a perimeter of 1, 2, 3, 4, 5, 6 for figure 1. For figure 2, I have a perimeter of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For figure 3, I have a perimeter of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
We're making bingo boards for the announcements.
I know, I'm pretty excited for the bingo boards for the announcements. I'm willing to bet that this looks pretty linear, right? We're adding 6 every time. I'm going to guess this one has 24.
We're also going to do code.
But let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I think we have a linear relationship here. So our equation, well, for figure 0, we have to go back to find our y-intercept. our slope is clearly 6, so at figure 0, we'll have 0 for our perimeter, which gives our equation P for perimeter is equal to 6 times the figure number. All right, so identify and describe the figure in the pattern that will be made with exactly 420 tiles. All right, so is that area or is that perimeter? Well, the number of tiles is area, right? So we know, and this is a little bit more challenging. So we have to go back to our area equation. So we know for this figure, n squared plus n has to equal 420. Well, is this quadratic or is this linear? Well, clearly it's quadratic. So to solve a quadratic, it has to be equal to 0 and in factored form. So my first step is to subtract 420 from both sides. And so that will give me n squared plus n is minus 420. And that has to equal 0. All right, so now we need to come up with two numbers, a pair of numbers that when multiplied together, they equal negative 420. But when you add them together, you get positive 400, or so when you add them together, you get positive 1. Now, I can't help but notice that if you add the two numbers, you get positive 1. That means the two numbers have to be only 1 apart. That means that the two numbers are going to be really, really close to the square root of 420, but not exactly the square root of 420. So a quick little trick on this one is I'm going to take the square root of 420. And it's going to be irrational, and that's okay. But that is telling me that one of my numbers is going to be a little bit larger than 20, and then a little bit larger than 20.49, and the other number is going to be just a little bit smaller than 20.49. I'm guessing that 20 times 21 equals 420. It does, look at that. So then we know that this can factor to n, and that's positive, so 21 has to be positive. 21 times n minus 20. And that again equals 0. So when you're factoring, or when you're solving a quadratic, you're going to break the variables apart and treat each one like a separate linear problem with train tracks. Minus 21, minus 21, so we're subtracting 21 from both sides. So we get negative 21 is equal to n. Can you have a negative figure number? No. So we know 21 doesn't make sense in the context of this problem. How about here? Add 20, add 20, and we get n is equal to 20. Can we have 20 as a figure number? Yes, we can. So we are going to discard the number that does not make sense in the context of this tile problem. And so figure 20 will have 420 tiles. Finally, question E. Describe the relationship represented by the equations in part A and C. Do any of these represent linear, exponential, or quadratic functions? And explain. Well, we all already kind of have explained it, but clearly question A talks about area, which is a squared situation. Problems or functions that have a squared in it are going to be quadratic. In question C, we have a linear relationship because this is written in y equals mx plus b form, where b is 0. That is linear. All right, I hope you enjoyed your summary and have a great day in the melting snow.